So if you're a developer, you know we've moved way beyond just making simple, single-prompt calls to a large language model. We're in a whole new era now. We're building systems that do a lot more than just generate text. We're building autonomous, goal-oriented AI that can actually take action. This evolution, it's called Agentic AI, and that's exactly what we're going to break down today. And that really brings up a key question for you, for the systems you're building right now. Are they just passive content creators, or are they active participants that can reason, plan, and execute tasks? This is the fundamental shift. We're moving from generative AI to agentic AI, where the model isn't just a brain in a jar, it's a brain with a body that can actually do things. And this isn't just a vibe, right? The formal definition really nails it down. Agentic AI is all about autonomy and decision-making. It's not just about writing an email. It's about a system that can decide to write an email, figure out who it should go to, what it needs to say, and then actually send it, all without a human needing to micromanage every step. Okay, so here's the game plan for this explainer. We're going to quickly cover what makes these systems tick. We'll start with that basic conceptual shift, then look at the core anatomy of an agent. Explore the essential design patterns you can use, see how they fit into cloud-native architectures, and finally, we'll tackle the big one, how to make these things production-grade. All right, first up, let's really frame this move away from just making single API calls, because there's a huge difference between prompting a model once and actually designing a true agent. You see, here's the real shift in thinking. We are moving from a single request and response interaction to a continuous iterative loop. An agent gets a high-level goal, it plans the steps, it uses tools, and it carries out a whole sequence of actions to get there. You know, it's the difference between asking a calculator for one answer and hiring a financial analyst to manage your entire portfolio. Okay, so if that's the what, let's dig into the how. What's actually under the hood of an agent? What are the fundamental principles that make an agent, well, an agent? Look, at its core, every single agent runs on this incredibly simple yet super powerful loop. First, it perceives its environment. You know, what's the current state of the world? Then it reasons. Based on my goal, what's the smartest thing to do next? And finally, it acts. It executes that step, which changes the environment, and then the whole loop starts all over again. And that loop? It's really held up by these three foundational pillars. Agents are asynchronous, meaning they operate in the messy, event-driven real world. They have autonomy, which is the freedom to make their own decisions without someone holding their hand. And they have agency, a clear purpose they're working towards on your behalf. Okay, theory's great, but let's get our hands dirty. How do we actually build these capabilities? Well, we use something called agentic patterns. Think of them as reusable design templates for specific behaviors. The most basic pattern, pattern 1, is just pure reasoning. An input comes in, the LLM thinks about it, and an output goes out. This is perfect for simple, single-step tasks like classifying a support ticket or summarizing a document. It's totally stateless, no memory, no tools, which makes it really fast and easy to build with. Okay, now this next one, RAG, is a total game changer. It solves one of the biggest problems with LLMs, the I don't know problem, or worse, the I'll just make something up problem. With RAG, the agent doesn't guess. When it gets a question, it first goes and searches a knowledge source, like a vector database, to find relevant, factual information. This makes its answers way more accurate and auditable. And this is where it gets really powerful. The tool use pattern literally gives the agent hands. Instead of just talking about something, it can actually call an API, query a database, or run a script. This is what transforms a passive assistant into an active system that can book a flight, order more inventory, or even provision a server for you. So we've got these patterns. Awesome. But how do we stitch them together into a real production-ready system that runs in the cloud, the kind of system we're used to building? So the big shift here is moving from what we all know as event-driven to something new, cognition-augmented. In a traditional system, an event comes in and triggers a predefined, hard-coded function. In an agentic system, that same event is handed to an agent that uses an LLM to dynamically figure out what the best next step is. The logic is no longer set in stone. And here's a perfect picture of what that looks like on a platform like AWS. A user request comes in, and the Amazon Bedrock agent basically acts as the brain of the operation. It uses an LLM for reasoning, it pulls context from a knowledge base if it needs to, and then it puts together a goal-oriented response or action. Now, for all you developers out there, this table is basically your blueprint, your cheat sheet. You can map every conceptual part of an agent directly to a managed service. Need that LLM reasoning? That's Amazon Bedrock. Need to run a tool? That's a Lambda function. Got a complex, multi-step job? AWS Step Functions is perfect for that. It's all right there, ready to go. All right, last section and maybe the most important one. Let's talk about the really hard part. Moving from a cool prototype that works on your machine to a reliable production-grade system. This is where the real engineering challenges kick in.
Okay, the single biggest headache you're going to face is something called non-determinism. Unlike traditional code, you can give an agent the exact same input twice and get two totally different outcomes. And that makes testing, debugging, and just guaranteeing reliability incredibly difficult. Just how bad can it get? Well, check this out. Research has shown that an agent with a pretty good 60% success rate on a single task can see its overall reliability plummet to just 25% when it has to do 8 of those tasks in a row. It's because small errors cascade and get worse over time. Standard testing just can't catch this stuff.
So how in the world do you build for this?
Well, you need a solid strategy, and it really comes down to these 4 things. First, your definition of success has to be more sophisticated than just pass-fail. Second, think about your architecture in layers, from the model all the way up to security. Third, pick the right framework for the job, maybe LangGraph for tight control or CoALA for moving fast. And finally, you absolutely must monitor everything in production to catch problems as they happen.
So what's the big takeaway here?
It's that these agentic patterns, they're not some crazy new thing from another planet. They are the next logical evolution of the event-driven, cloud-native architectures that we already build and understand. We're just swapping out our static, hard-coded logic for dynamic, LLM-powered cognition.
Which kind of leaves us with this one last big question to chew on. As these systems get more and more capable, as they start to plan and reason and act with more autonomy, the line really starts to blur. Are we just architecting more advanced software systems? Or are we actually on the verge of designing our first true digital colleagues? That's something to think about.